The lesson today is on 3 trigonometric functions. There's a blank copy of the notes posted if you want to follow along, and feel free to pause the video at any time to try the problems before I do them. Today we're learning about 3 trigonometric functions: sine, cosine, and tangent. These 3 trig functions give you a ratio of 2 sides in a right triangle. If you look at our right triangle here, this symbol means theta. It is a Greek letter. This is the angle that they're talking about in this triangle. With respect to this angle, we can label the 2 legs of the triangle. The 5 is opposite theta. So we can label it as the opposite side. The 12 we call adjacent, and the 13 is the hypotenuse of the triangle. Sine is the ratio of the opposite side divided by the hypotenuse. So in this triangle, the sine of theta is 5 divided by 13. The cosine of the angle is the adjacent divided by the hypotenuse. So in this triangle, the cosine of theta is 12 over 13. And the third trigonometric function is tangent. The tangent of an angle is the ratio of the opposite side divided by the adjacent side. So in this triangle, the tangent of theta is 5 over 13. Typically, when we do these trigonometric ratios, we're going to leave our answers as simplified fractions. Let's try another one. In this triangle, the hypotenuse is missing. But because it's a right triangle, we can use Pythagorean theorem to find the missing side. So we have 4 squared plus 6 squared equals c squared. 16 plus 36 equals c squared. 52 equals c squared. So c is the square root of 52. Another way to write that is c equals 2 square root of 13. And you can get that by breaking 52 down into 2 times 26 and 26 down into 2 times 13. Our pair of 2's we can pull out to the front. So now let's go back and label our hypotenuse. 2 square root of 13. Now the angle's in a different spot this time. If the angle's at the top, now the opposite side is on the bottom because that's the side across from the angle. The adjacent side is the 4, and the hypotenuse is now 12 square roots of 13. Our trigonometric ratios are still the same ratios though. So now we're going to do the sine of theta is the opposite over the hypotenuse. So it's going to be 6 divided by 2 times the square root of 13. We can reduce 6 over 2, making it 3 over the square root of 13. And then after we rationalize the denominator, It's 3 square root of 13 over 13. Cosine is the ratio of the adjacent side over the hypotenuse. The adjacent side is 4, and the hypotenuse is 2 square root of 13. So 4 divided by 2 square root of 13. We can reduce the 4 over 2 to be 2. And after we rationalize the denominator, it's 2 square roots of 13 over 13. The last one is tangent, and if you remember, it's the opposite divided by the adjacent. So the tangent of theta for this triangle, or in this angle, is 6 divided by 4. 6 over 4 reduces to 3 over 2. And that is the sine, the cosine, and the tangent of this angle. Now, practice labeling the sides as opposite, adjacent, and hypotenuse. Feel free to pause the video and then check and see if you got your answers right. Let's practice again. Write out the trig ratios for the following triangle. This time it asks for the sine of A. A is labeled as this angle. The opposite side is over here, hypotenuse and adjacent. The opposite side is missing, so we need to do the Pythagorean theorem again. $72 breaks down into 2 times 36, which breaks down into 6 times 6. So the square root of 72 reduces to 6 square root of 2. So the opposite side is 6 square root of 2. So the sine of A is opposite over hypotenuse. So 6 square root of 2 over 11. 6 over 11 does not reduce, so we leave our answer like that. The cosine of A is the adjacent over the hypotenuse. So 7 over 11. And the tangent of A is opposite over adjacent. So 6 square root of 2 over 7. We can use these ratios to find missing sides if one is missing. Look at this example. 25 degrees is the angle given. X is the opposite side, and 27 is the hypotenuse. So we have the opposite side and the hypotenuse. Looking at our 3 trig ratios from before, we see that sine uses the opposite side over the hypotenuse. So we can write that the sine of the angle is equal to x over 27. So the sine of 25 degrees equals x over 27. To solve this equation, you simply multiply both sides by 27. That will cancel the 27s on the right-hand side. Now get out your calculators. We first need to make sure that your calculator is in the right mode. Hit the mode button on your calculator, which is right next to second. Make sure degree is highlighted on your calculator screen. Now go back and type in 27 times the sine of 25. That is the answer for x, and that's the missing side. Let's try another example. Take a look at this triangle. This time, 13 is the adjacent side, and x is the hypotenuse. We need to think of a trig function that uses the adjacent side and the hypotenuse. If you look at your notes from before, you'll see that cosine uses the adjacent and the hypotenuse. So we're going to write an equation using cosine. So the cosine of 67 degrees equals 13 over x. When x is on the bottom, it's a little bit trickier to solve. You first need to multiply both sides by x so that it's no longer on the bottom. So now we have x times the cosine of 67 degrees equals 13. Now, the opposite of multiplication is division, so divide both sides by the cosine of 67. Now go back to your calculator. This time type in 13 divided by the cosine of 67. So x is 33.27. The next worksheet is a lot of practice on this topic. You can pause the video and try the practice problems. If you would like to see one more example, keep watching. In this triangle, 6 is the adjacent side and x is the hypotenuse. So looking from our notes before, we need to use cosine because that is the ratio of the adjacent over the hypotenuse. So the cosine of 72 degrees equals 6 over x. When x is on the bottom, you first multiply by x. And then divide by the cosine of 72. So x is 19.42. One more example. Let's look at number 3. In this triangle, x with respect to this angle is the opposite side. 12 is the adjacent side. So if you look at your notes from earlier, we need to use tangent because that's the ratio of the opposite side over the adjacent. So the tangent of 24 degrees is equal to x over 12. To solve this, you multiply both sides by 12. .34. Now try the rest of the problems on the worksheet and check your answers with the answer key posted.